Okay, this is 1.8. We're going to be talking about inverse functions. It's the very last section in chapter 1 that we need to cover. So go ahead and get yourself all set up and ready to go. So what do you guys already know about an inverse functions? Nothing at all? Nothing. They're opposites? Okay. Okay, so I figured that, I'm assuming that we don't really know a whole lot about inverse functions, and that's fine. So to begin with, I just want to play around a little bit. I've written the same two functions on my little computer system over here. Right? I have f of x, and that's equal to x squared, and I have a g of x, which is the square root of x, okay? So if I ask the calculator for, I don't know, like, how about f of 5? If I had the calculator for f of 5, what's this thing going to spit back to me?
It's going to spit back 25.
It's going to spit back 25.
Square root 5.
Well, no. Just f of 5, right? F of 5 is 25, okay? So now, what if I ask the calculator for g of 25? What's it going to spit back? It's going to spit back 5, okay? So, what if I ask the calculator for f of 3? What's it going to give me? F of 3 is going to give me 9. Okay, what if I ask the calculator for g of 9? What's it going to give me? It's going to give me 3, right? So, go ahead and follow the journey here. Let's take, for example, the number 5. Okay, here's what we did. We took the number 5 and we plugged it into the f function, and we evaluated f of 5. Is that true?
Yeah.
And then we got what number?
25.
And then we got 25. Then we took 25 and we plugged into the g function, g of 25. And what did that give us for the end? 5. So, do you notice that we started and we ended up in the exact same spot?
Yes.
Right? And that we saw that that was true for the number 3 as well, right? So this is paramount to understanding what an inverse function is. It just takes whatever you did before and undoes it, gets you back to where you started. So I'll say that again, right? It takes whatever you did before, it undoes it, and gets you back to where you started. So for example, we started with a 5, we plugged it into f, we got 25. We took 25, plugged it into g, it gets us back to 5. So an inverse function, right, together, collectively, they just cancel each other out, basically, right? One gives you back exactly what you started for the other. So g of x is the inverse function to f of x because it undoes exactly what f of x does to the numbers. Does that make sense to you? That's the idea of what an inverse function is. Yeah, Michael? So once we have a fundamental understanding of what an inverse function does, right? They do undo each other. They're basically the inverse operations, they undo. Then the first skill that we have to have is we have to show how to actually verify that one function is the inverse of the other one. So this is what we're going to do. I have the same exact two functions written down, okay? In order to show that one function is the inverse of the other one, we have to do two things, okay? So here's what we need to do. We're going to check. The first thing that we're going to check is this. We have to show that f of g of x gives us back x. Hey, what is that notation called, f of g of x? What was the last lesson that we did? Function composition, right? So we actually have to use function composition in this lesson to verify that two functions indeed are inverses of each other. So f of g of x, this means this, right? This means f of g of x. Is that true, everybody?
Yes.
And we want to show that that's equal to x. So basically what we're saying is that whenever you put in, you get back no matter what you do, right? Like f of g of star should be star. F of g of heart should be heart. So no matter what x value we pick, we're just going to get back whatever we started with. That's how we show algebraically that two functions are inverses of each other. Does that part make sense to you? Okay, so what is g of x?
Square root of x.
Yep, the square root of x. That's what it's defined to be. And we want to make sure that this is equal to x. Now, what do I do with that square root of x? I plug it into which function? F of x, right? So I would have this. I would have the square root of x. I would take that quantity, and then I would square it. And I want to show that that's equal to x. Is this looking true so far? It sure is, right? Because the square root and the square root cancel out. So therefore, x is equal to x. That's the first thing that we have to check. The second thing that we have to check is we have to show that g of f of x is also equal to x. So basically, we have to show that it's true for both directions, no matter which way we go. Either f of g of x or g of f of x. So we're going to do the exact same procedure. So this literally means g of f of x. And we want to show this is equal to x. So this is g of, what is f of x defined as, ladies and gentlemen?
Squared.
It's x squared. So what do I do with that x squared?
Square
I
root.
plug it into the g function. So I take the square root of x squared, and yes, absolutely, that's definitely equal to x. So therefore x is equal to x. And we have shown both directions happen to be true. So if this is the case, then we say this. We say the following. We say that g of x is equal to f inverse of x. So there's some new notation right here.
Can you say f of x equal to g inverse of x?
Yeah, the reverse of it? Yeah, you can. But most of the time we keep it in f, right? So this is read f inverse of x. That's how we read that in English. F inverse of x. Okay? So how'd you read this in English? How'd you read that in English?
C inverse of x.
C inverse of x, right? Okay, how'd you read this one? D inverse of x. That doesn't mean d to the negative 1. It doesn't mean 1 over d. It's in this particular unit is referred to as the inverse. So that's how we say. Okay, we want to show that g of x is the inverse of f of x, okay? And I just want to show or talk through exactly what's happening to these functions. Let's focus our attention on f for just a moment, okay? Let's just focus here for just a second. If you give me an x, let's say you give me a value of like x is 3. You say, or how about 5? You say, okay, what am I going to do if x is 5 in the f function? I'm going to take your 5, I'm going to multiply it by 3, and then I'm going to add what? 2. So you give me a 5, I take your 5, I multiply it by 3, then I add 2. So I'm multiplying and then adding. Take a look at what g is doing. You give me a number, instead of adding 2, I'm now subtracting 2, and instead of multiplying by 3, I'm now dividing everything by 3. So intuitively, it seems like g of x would undo all the little pieces that f of x does. So it seems like we have a pretty good understanding, right? Let's do an example. Let's do 5 again, right? What is f of 5? It's 17, right? Exactly, because if I plug it in, I would get 5 times 3 is 15 plus 2 is 17. Now what's g of 17? Well, 17 minus 2 is 15. 15 divided by 3. It gets me back to 5 again, right? So it seems like it works. And in fact, we just verbally discussed that it would work for f of 5. Now let's actually show it with algebra, okay? So how do we actually show this thing? We don't just plug it in. What do we do, you guys? We have to check these two pieces of information right here. This is how we do it. We check f of g of x, and we want to show that we get back x. And then we also check g of f of x and show that we get back x. So here's the procedure. So I want to check f of g of x. So that, and we want to show that this is equal to x. So this means f of g of x. Show that's equal to x. So this is f of, what is the g of x defined as? No. X minus 2 divided by 3. Right? Because, right? I want to evaluate f of g of x. So that's this thing right here. And I want to show that I get back x for this thing. Now, what do I do with that x minus 2 over 3? What do I do with that? Plug it into f, right? So this is going to give me 3 times the quantity x minus 2 over 3, excuse me. And then I want to add 2. So does everybody realize that I just took this information and I plugged it in right there for the x? And that gave me this piece down here. Everybody see that? Okay, cool. Now notice what happens. 3's cancel out. And I'm left with an x minus 2 and then plus 2 on the outside. And I'm trying to show that that's still equal to x. Is it, everybody? Yeah. It sure is, because the 2's cancel out, so x is equal to x. So I'm halfway done with the problem. What's the other part that I need to do? Exactly. You guys got it. I want to show that g of f of x is also equal to x. So this is going to be g of f of x. Show that it gives me back x. So this is g of what is in the inside? 3x. Very good. So I want g of 3x plus 2. And show that gives me back x. What do I do with that 3x plus 2?
And then you do 3 times x plus 2 over 3.
No, I take this information. What do I do with this? I plug it right there. Okay? So I get 3x plus 2. And then I subtract 2. And then I divide all that by 3. And I want to show that that's equal to x. Is it?
Yes, indeed.
It totally is, right? Because I have the 3x plus 2 minus 2. That cancels out. So that leaves me with nothing more than 3x over 3, and I want to show that that's equal to x. Well, the 3's cancel, so x is equal to x. And now we have shown that g of x is the inverse of f of x. Okay, I want to show you something about these two particular functions. Their graphs are very interesting, and their graphs are very meaningful. So let's graph both of these at the same time on the same, well, that didn't work out, on the same graph. Okay, here we go. So there we go there. The red one represents 3x minus 2. The blue one represents x minus 2 over 3. Do you guys notice anything about these graphs? Do they look special to you? Do they look interesting to you? No.
They intersect.
They do intersect, yes. Okay, they make an X, okay. Do you guys notice any sort of symmetry whatsoever?
They're both aligned.
90 degrees.
Oh, it's like in geometry when like the two angles hit each other.
Okay, all right.
It's like
The vertical,
the
okay.
areas
Okay.
that go out
Okay.
like that.
Can you give me a very easy point? Actually, here, I'll give you one. Do you guys agree that this point is on the graph of the red curve? What point would that be? 0, 2. Okay. Now take a look at the blue graph. What point is over here? 2, 0. Whoa, wait a minute. What did we do?
Math. Inverse.
All we did was the x and the y coordinates were switched, right? Give me another point on the red graph you can clearly see. How about that one? Where's that one at?
-2, -4.
-2, -4. Okay, now look at the blue graph. -4, -2. Oh.
That's just like a coincidence.
Yeah, it's not a coincidence. That's a really cool thing. Okay? Now here's the point that I really want to make. Are you guys familiar with this line right here, the line y equals x?
No. Basically.
Okay? What is that line going to look like?
Right through the order.
Right through the origin, it's going to be a diagonal. Now do you guys notice any symmetry?
Yeah.
Yes, there is symmetry, right? Any function graphed with its inverse is just going to be reflected over the line y equals x. Pretty darn cool. And the way that we create those graphs is by just flipping the x and the y coordinates. We're going to do a little bit more of this, but I wanted to point that out. All right, the next thing that we're going to learn how to do is we are going to learn how to actually find the inverse of f of x. Okay, now this part I think you have seen before. There's a series of steps that we're going to do. So I'm going to give you this function, f of x equals x plus 7 divided by 4. I'm really interested in figuring out the inverse of x. So I want to know what it's going to be algebraically. So here's what we're going to do, and I think you've seen these steps before. The first step is we're going to change f of x to y. So y equals x plus 7 over 4. This is kind of an arbitrary point, but it helps us do the third step. Okay, so y is equal to x plus 7 over 4. Now, I'm going to switch x and y. So x is equal to y plus 7 over 4. Who has seen this before? Okay, come up, yeah, hands are going up. Good. Now, at this point, I'm going to resolve my equation for y. Okay? So go ahead and help me out. If I'm going to resolve this for y, what would I do? Multiply both sides by 4. So multiply that side by 4, multiply that side by 4. So I would get 4x is equal to y plus 7, because that cancels out. And I want to solve for y, so what would I do next? I would subtract the 7 from both sides. Subtract the 7. And I would get this. I would get that y would now be equal to 4x minus 7. And then the very last step is I would change this into my inverse function. So f inverse of x has to be 4x minus 7. Okay? And that's how we do it. So let's go ahead and list the steps. What was the very first thing that I did? Yep. So we change f of x into y. What was the second thing I did? I switch the x and the y. What's the third thing I did? Yeah, I'm going to say like resolve, right? Resolve for y. And what's the fourth thing I did?
Put it back into inverse.
Yep, change y into f inverse of x. So that right there is a really nice procedure for you to be able to follow to produce the inverse function. Those 4 steps, really good procedure. So maybe you want to highlight box number 3, go back to the video and watch it, okay? Let's play with this a little bit. Let's go over here. What was the very first function I gave you?
X plus 7.
X plus 7 all divided by 4, right? Okay, let's graph this one. Okay, it's a line, no big deal. I see the line there. Okay, what was the inverse function that we came up with? 4x minus 7. Let's go ahead and graph this one. Do those look symmetric? Over what line?
Over the x, y equals x.
Okay, if I graph this line on there, does that look like we did it right? It certainly does, or it definitely does look like we did it right, okay? So if I took a point on the red graph, can you guys find a really easy point on the red graph that I could use? On the red graph, 1 comma 2, right? 1 comma 2. So this is the point 1 comma 2. So if I switch the x and y coordinates, what would I get?
-1, negative.
I would get 2 comma 1. And look, there's that point right there, 2 comma 1. What about this point over here? -3 comma 1. If I switch them, what would I get? 1 comma -3. So you guys seeing the connection between what the graph looks like and the steps that we're doing? Right? So check it out. We're switching every single x for every single y. That happens right there in step number 2. Isn't that a neat little thing to see? Okay. So box 4 is the you try. It's going to be find the inverse function. I'm giving you the function f of x equals 5 over x plus 4. I want to graph that function just to see what it looks like. Okay? So y equals, what was it, you guys? It was 5 over x and then a plus 4, right? Did it get it? There we go. Okay, if I graph this, hey, does that look like a line to you? No, it's the Hurley graph, right? That's the 1 over x function. Notice it's been moved up 4 units, right? Okay. So whatever we do, whatever we come up with, it needs to be reflected over what line, you guys? It needs to be reflected over this line. So whatever we do, we should see a reflection over that line, okay? So right now I want you guys to go ahead and try and come up with the inverse function to 5 over x plus 4.
No.
Okay, ladies and gentlemen, we're going to do some investigating. This is the cool thing about this particular program. If we got this right, what should we expect to see on the graph? A reflection over the blue line. So let's do this one first. Nope. That's a line, right?
Which one did we do first?
The 5x minus 20. So let's take this one away. It's not that one. And the cool thing is the graph goes away. How about this one? Let's put this one on the graph. It's definitely not a line, but do you think that's been reflected? No, it hasn't been reflected. So let's take this one away. It's not this one. Okay, what about this one? Let's see what we have.
It's correct.
Nope, that's a line too. That's a line too. It's definitely not that one. Okay. Okay. All right, so we're having some troubles with this, so let's work it out together, okay? What's the very first thing we do? Y equals 5 divided by x plus 4. Everybody cool with this part?
Yes.
Then what do we do?
Switch them.
Switch x and y. So x is equal to 5 over y plus 4. Then what do we do? Resolve for y. So if I resolve for y, I would get what? Maybe let's go x minus 4 equals 5 divided by y. Now here's the kicker, you guys. This is an entire number, so therefore y is just equal to 5 over the quantity x minus 4. So therefore f inverse of x is equal to 5 over x minus 4. Okay.
So you basically swap.
Here's the thing, you guys. If I have a is equal to b over c, then c is equal to b over a. That's an algebra 1 thing, okay? That's an algebra 1 thing, all right? So we think it's 5 over x minus 4. So let's go back to this and graph this. Y equals 5 over an x minus 4. If I put this one on the graph, hey, there it is.
So you're about to do like
Now it's been reflected,
switch
okay?
the variables.
Here's another little quick example to help us out. Let's do f of x equals 2 over x plus 1. Go ahead and find the inverse. Emily, think you got it? Okay, what do you have?
Oh,
She says 2 over the quantity of x minus 1. Let's go ahead and see. Hey, does that look pretty good to you guys? That looks pretty good to me. Look, they are definitely symmetric over the line y equals x. So the graph verifies it, absolutely.
Velocity.
VLT. Okay?
Volume
Who's ever heard of the vertical line test?
Yeah.
Yeah, baby.
The vertical line test. Okay, what does the vertical line test help us do?
Determine if it is a function or not.
Yeah, so if f of x passes, if it passes the VLT, that's what I call the vertical line test, then what?
It's a function.
There, very good. Then f of x is a function. Okay? That's the VLT. That's the first one. Okay, the second one is this. Who's ever heard of the HLT? What's that one stand for?
Horizontal line.
The horizontal line test. Absolutely. The horizontal line test. Now, what does this one do?
Defines it's not a function.
Okay, well, we're on the right track, right? So if f of x passes the HLT, then f of x, then f inverse of x exists and is also a function. A loss also. Okay? So if a function passes both of them, if it passes both, then we call that function a one-to-one function. This is a new term for us. Okay, a one-to-one function. So a one-to-one function is a function that passes both the horizontal and the vertical line test. I'm going to give you two examples fairly quickly of each types of these, okay? Okay, so here we go. Here are two examples, right? The one on the left is a function, but it's not one-to-one. And the one on the right is a function, and it is one-to-one, okay? So this one right here, right? This is a function because it passes the the vertical line test, right? However, it does not pass the horizontal line test because I hit two spots at once. So this is just regular f of x equals x squared. That is a function, but its inverse is not a function because we have to restrict the domain. However, in this one, right, this is the graph f of x is equal to x cubed. Do you see the difference here? Right, this one will pass the vertical line test, so it's definitely a function. And in addition to, it does pass the horizontal line test. Now everybody always gets upset around 0 and says, well, at 0 it looks like it goes flat, but it never actually does go flat at 0, okay? So this function is 1, 2, 1. Does that make sense? So you have to know what that term means, 1 to 1. Okay, box number 6 is the very last one. I've given you a dummy function, f of x. I just created it really quickly. It's pretty simple. And I gave you 3 points, all right? Is this a one-to-one function?
Yes.
Yeah, it is. How come?
Because we can do
It passes the vertical and it passes the horizontal. Okay, now what I want you to do is I want you to graph the inverse of this function. Okay, we're going to graph the inverse. Well, how are we going to do that? Well, we're just going to very simply switch the x and the y values, right? So instead of -4, -1, what would I have?
4, 1.
No. I would have -1, -4. Okay? -1, -4. Okay? Instead of 1, 2, what would I have? I'd have 2, 1. Okay? 2, 1. Alright? And instead of 5, 3, what do I have? 3, 5. Maybe that one. So I'd use the straight edge and I'll graph that. So notice that the inverse is also a function, right? Now, something I really want to point out, I know that we have to go, but the domain for my function f of x would be this. All real numbers x such that -4 less than or equal to x less than or equal to 5. Does everybody agree with that part?
Yeah.
Okay, I go from -4 to 5 in my blue regular old function. The range of my blue function f of x would be, what's my lowest y value? All real numbers y, my lowest y value is -1, less than or equal to y, less than or equal to 3. Is everybody cool with that part? Okay, now, notice the domain of the red function. What's the domain of the red function? It's my lowest.
It's the same as the range.
Yes,
Of the other one.
there you go. It is exactly the same as the range of my inverse function. And the range of f inverse of x, by the way, this is called f inverse of x. The range of f inverse of x is the same thing as the domain as the regular function f of x. That's going to be an important role later on today. Okay, guys, that's it.